All right, guys, welcome back. We're looking at Invader Part 3. So let's take a quick recap of where we are. If we look, I'm going to tell the game view to maximize, and we're going to play and see where we left off. So we can move, shoot, and get chased by our enemies. It's kind of fun. It's almost pretty to watch. So yeah, so right now shooting doesn't do anything, so we are screwed. And also getting attacked doesn't really hurt us, so I guess that's good. But we're going to go through and kind of make it so that enemies can take damage, players can take damage, and if there's any time left, we'll go a little further. So I'm going to make that small again. If we look back at the code, excuse me, we set this up like, players are going to have HP and speed. Enemies are going to have HP and speed, and so they're going to have this common ancestor, right? They're all entities. So we designed entities as sort of like the parent class, and then we inherit from that for player, and we inherit from that for enemy, and maybe we'll have like, I don't know, an ally, and we'll inherit from that or something like that. Like it just gives us more options and flexibility in the future in an effort to not repeat ourselves. So excuse me. So in the game manager, we start off when the game starts, we create the enemies. How do we do that? Well, we have a value called starting enemies that we get to set. We have it set to public, so we can, in the inspector, say I want 20 starting enemies. And then this function gets called. So we talked a lot about the coding last time, right? So on line 12, I'm calling a function called create enemies. I'm saying, computer, at this point right now, I want you to do the create enemies thing. That's fine. Ahead of time, we told it what create enemies should do. So here on line 17, we define the function, right? So when you define a function, you're explaining to the computer, hey, this is what you should do when you create enemies, right? So the instructions are here in the function definition, and it actually gets executed whenever you call the function, which happens here on line 12 in the start function. Okay, so I'm not going to belabor this too much. We talked about it a lot last time, but while starting enemies is greater than 0, right? So let's say I said I wanted 20 starting enemies. So while 20 is greater than 0, instantiate. So what does instantiate mean? It's to create an instance of instantiate. So we're instantiating an enemy prefab at a random position, and quaternion.identity is just sort of like saying with the default rotation, because Unity's fussy. Don't worry about it. So when we do that, we're going to keep track of our enemies and say we just made one, so let's add 1 to our enemy count. I think later we'll probably make it so if there's no enemies left, we win the game. So it's an important value to keep track of. And then when we're done instantiating, we go down and we say, okay, starting enemies minus minus. So what does that mean? Minus minus is the same as saying -1, right? So starting enemies is now equal to the value that was starting enemies -1. So if it was 20 before, it is now 19, right? So minus minus is just a shortcut for saying that. So we're resetting the value of starting enemies to be 1 less than it was. So, the first time if this was 20, 20 is greater than 0, the while loop is correct. 20 is greater than 0, so we do this stuff. Then we change it. 20 becomes 19. Starting enemies becomes 19, so we go back up. That's the power of a while loop. It'll keep going forever as long as the thing in the parentheses are true. Very useful, but if you don't have a way to stop the thing in the parentheses being true, then eventually you're going to get what's called an infinite loop and your computer's going to crash. But we will not have that problem here because 19 is greater than 0, blah, 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 minus, minus. 18 is greater than 0, blah, 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 minus, minus. 17 is greater than 0, all the way down until it gets to 0, which is not greater than 0. So then the while loop goes, I'm good, and then moves on. Okay, hope that's good. We did random position. You can see we're getting some random numbers and we're using it to generate a random vector 3 to instantiate enemies at a random position. I think that all makes sense. All right, let's look at the player, right? I think what we should start with is being able to kill the enemy. So let's see, the player in the update loop, we're checking to see, are they hitting the space key, right? So I remember we're using this library called Dark Magic. It's a little framework I put together to make certain things simpler. So that lets us use this I syntax here. So I is for input. I just named it that way to keep it short. So this is the way Unity used to do their input code. It was simple. It was quick. The new input system is awesome. It's just a lot more work to set up. So for prototyping and simple things, I like to use this syntax. So that's what we're doing here. So I'm saying on line 17, if the player hits the space bar, call the shoot function. All right, so I'm saying call the shoot function, execute, shoot, do the shoot stuff, right? And so that's where they should do it when they hit the space bar. But, you know, I told them what that means down here on line 32, right? Void, shoot, and then curly brackets lets me tell them what should happen every time shoot happens. And so it's just one line right now. We're instantiating a bullet at a position, at the position of the player. And again, this default rotation. So I could put one step here, or I could put 20 steps here. All of them will get executed every time the shoot function gets called. And so I think that hopefully makes sense. I think we're good there. You know, the reason we want the bullet to be instantiated at the player's position is because that would make sense, right? The bullet should come from wherever the player is. So by putting transform.position here, I'm saying use the current position of the player, right? You could also write it as this dot transform dot position. But you don't need to, because that's implied because of the way Unity and C# work. So just to make it a little clearer, we're talking about the player's transform.position, and that's where we want the bullet to appear. Okay, so all that seems good. You know, we can contrast that with the enemy, actually the game manager, where we instantiate enemies at a random position. And if you notice, this is a function, right? So instead of putting a value in this spot, we put a function that returns a value, right? So most of the functions we do have this void keyword, right? Handle movement has a void in front of it. Shoot has a void in front of it. Even start and update, they have a void. That means you're defining a function that does not give you a value at the end of all the steps. But you can have a function that gives you a value at the end of all the steps, right? If I just simply had a function that was like add, right? Add 2 and 3. Well, I need to know the result of that. So it returns an integer 5, right? Maybe you can see that in your head. If I wanted to actually write that, it would be like this. Right? So instead of void as the keyword, as the return type, I'm using int. Int is for integer. It's a number. I'm sure you guys already know that. And so the add function here requires 2 pieces of information to do its job. They're both ints. We're going to just call them A and B. We could call them anything we want. We get to name the stuff inside the parentheses. We get to name the function, right? I could call it add woo, and I could call it apple and banana. It doesn't matter. I get to say what those things are as long as I'm consistent, right? So probably seems like a weird example. I'm just trying to show you the things that you get to name. You know, like int, that's built in. That you have to use. Int means integer. That's just a thing that's part of the code, right? Return, you know, that's always the thing you use at the end of a function to say, okay, return this back to where it was called, right? So for example, this function doesn't really, we don't need to keep it, but it's a nice little example. If we go over here, we see vector 3 random position, right? So instead of void here, we said vector 3. That's telling the computer, okay, when this function is done, it's going to return a vector 3 value that we can use, right? And sure enough, look, return a new vector 3 with this random number and, you know, other stuff. And so what that means is we said return as the last line of our function. When we do that, that means when the value is calculated, it gets popped into this spot as if it's a value, right? So this is the part that people, you know, I've taught beginner programmers for a very long time, and I know we're kind of rushing here because we're trying to learn Unity on top of coding, right? So no worries. And if you already know all this stuff, just think happy thoughts for a minute. But calling a function in here, if the function has a return value, it basically calculates that value and pops it in this spot, right? So if this vector 3 is, 3, 1, 20, then it's going to do the instantiate function at this moment as if this is 3, 1, 20 of vector 3. So I hope that makes sense. I know I'm repeating myself, but I'm trying to go a little bit more nuanced each time so that hearing it a few times is always necessary. If you're not quite getting it, that's normal. Think of it like they call it a programming language because it is like learning a language. It really is. And so you got to hear it a lot of times. You got to see it a lot of different ways. You got to immerse yourself and you got to be confused for a while. It's not comfortable, but it's how it works. So hang in there. Okay, so I hope all that's helpful review. I guess I'll save our little add example in case, because I think it's a simpler, way to see how functions return and how that works. So, but what we need to do now is we need to make it so that when we shoot a bullet, it can hurt an enemy. So let's take a look at where we're at, right? That was all code, but we have a game to build. So we actually do have an enemy in our scene. If I double click, it'll bring us to it. I can kind of scoot around my scene and get a rough representation. We could be using some of the tools here to make it a little more in line with what we're seeing in the game view, but for now, don't worry about it. But because we're generating all of our enemies from the prefab, we don't actually need it in the hierarchy anymore. So over here, we can actually delete it from our scene. It doesn't matter, right? We hit play, they're still going to show up. Because when you're doing things from prefabs are files on your computer. They're files in the project. So it can do what it needs to do. So it's kind of nice. It's like a safe template that you can use. So if something gets messed up in your scene, well, if you're generating it from a prefab with code, it actually doesn't matter. I've seen projects where they have literally nothing in the scene and they just have a very specific game manager script type thing that at the beginning just through code loads in everything it needs in the right order and make sure that we're good to go. So different strategies for bigger projects. We don't need to worry about it right now. But although I just deleted it, I kind of do want it back because it's nice to see in the scene what it looks like, right? So our enemies have a box collider. That's all they have, right? I don't know how much we've seen of collisions in 3D in Unity. Problem with Unity is like it's 20 different things to 20 different people. I know people who've never used 3D and only do 2D. I know people who've never used the physics system and only use the UI system. I mean, there's a billion ways to build Unity games, so I'm not assuming anything. So I'm going to go over the basics of collision. Using the physics system in Unity, objects can collide depending on how you move them, depending on what components are put on them. You can make it so that they can physically collide with each other. Physically, right? So it's as if they're physically colliding. They bump into each other. They can't move through each other. You can make it so that they will sort of detect if they touch, but they'll still move through each other and sort of everything in between. So the box collider is the first way we do that, right? So our enemy has a box collider. If I go to our prefabs and I look at our bullet has a capsule collider. So this is a good start. Right, both of them have colliders. That means, okay, we can be in the physics system and we can interact with it and we can detect collisions, right? So the problem is the physics system is a little finicky, and depending on how there's many different ways we can set it up, and they have different strengths and weaknesses, benefits and pitfalls and fallbacks. So you might have heard the term rigid body. It's an actual real world science physics term that Unity uses to describe objects that take up space, that bump into each other, right? So often the easiest way to set up collisions is to assign a rigid body component to one or both of the things that you're trying to collide. That works. And so the other option is a trigger, which is an option you can do on a collider. So if we look at the box collider, there's this checkbox that says is trigger. So if you make a collider a trigger, it will not resist if something collides with it. It'll just go through it, but it'll know it touched something. That's the difference. So colliders that are not triggers are trying to actually take up physical space. Colliders that are triggers are aware when they collide with something, but it doesn't stop the movement. Okay, I hope that makes sense. I'm going to take a sip of coffee. You guys like the mug? It's got constellations on it. Okay, so right now, let's take a look at what we've got. And I'm going to try and go through every step of the process as I figure it out, because I think collisions can be a little bit misleading and a little bit tricky, and there's a few common pitfalls. So let's look at our bullet script, right? Let's think about how we want to do this. So our bullet script is very simple. It starts, it will destroy itself after 5 seconds, just so we don't get a billion bullets if we miss. And then its only job is to move that way, right? That's all it does. So a couple of options for how things might go. We might want to think about this in one of two ways, right? Do we want to say, okay, I'm the bullet and I want to know when I collide with something, and if it's an enemy, I'm going to destroy the enemy? Or do we want to flip it? I'm the enemy and I want to know if a bullet collides with me, and then I will know that I have to be destroyed. To some degree, either will work, right? But let's think about it. The other option is, do we want the bullet to like be a physical thing? I don't really think so, because we're in space, everything's lasers, it looks bright and weird and abstract. So I think it's fine if we don't have it so like the bullet like knocks the enemy back. And for now, I think we're just gonna have one shot kills an enemy. So we'll keep it simple. So what I'm gonna do is I actually think I'm gonna just do it on the bullet. And so when you have a collider component on a game object, you can get a sort of free function. So it comes with Unity, so you have to name it this way. It's built into Unity. So on collision enter is 1, but we might try and make it a trigger. So I'm going to say on trigger enter, right? And we're going to go through this. Sometimes the autocomplete is stupid, so just be on guard for that. Void private void doesn't sound right. So so on trigger enter is a built-in function that you get when, if we look at our bullet, you have a collider and you've checked this box, which I just did now. So if you're following along, check that box. You check the box that says is trigger. Again, this is the kind of collider that can tell if something touches it, but it doesn't interfere with the movement, right? So all we're going to do now is it's got this trigger collider now, and that lets us use this function. So we're going to check and see. This function should get called automatically when a bullet intersects with something, collides with something, when its space is occupied by something other than just itself, if that makes sense. I think I'm over explaining it now. So on trigger enter, that's a common programming pattern for things that kind of could happen at any time on something happening, right? So on something entering the zone of my trigger collider, then we're going to debug. Debug.log. We're gonna say, okay, something happened, right? We'll start with that. So if anything enters the zone of the bullet's collider, it's gonna debug.log. Let's see if that works though. That should work, but let's see. So I'm gonna hit play on the game. I'm gonna set it to maximize the game on play so we can see better. Yeah, there we go. So I hit play. All right, so I shoot a bullet, shoot a bullet, shoot a bullet. It definitely went through, right? Did I get any messages? I'm gonna hit pause. But if I look in my console, nothing, right? So that's a bummer. So it should have worked, right? And just to be super sure, I'm going to actually hit play one more time. And I'm going to look at it in the scene view. So I'm going to look, right? So here we have all these enemies, and they have descended upon our poor player. And, their Y position is 1, their X position and Z positions are what they are. But I just want to make sure that our bullet is actually hitting the enemy, right? Because that's one thing you have to worry about with colliders, is if they're not actually touching each other, you're not going to get the effect. I think there's another reason we're not getting the effect, but baby steps. So I want to just take us through the process of setting up and debugging colliders. So I'm going to restart just real quick. I'm going to hit play. And now things are happening. So I'm going to make a bullet and pause. So where's my bullet? My bullet is at 0, 1, -6. And as I unpause, we can see it's moving up the Z dimension. And we can see it's just about to intersect with this cube, right? So if I zoom in to the bullet, we're like right there, right? There's no way it's not going to hit that cube. So we know that it is actually connecting. So boom, went right through it, right? We actually got to see it. And so we did not get our message in here, right? So the thing is, it is probably that we need a rigid body. For collisions, for the collision system to work the way you want it to work, one of them needs to have a rigid body. So let's try it. Let's see what we're working with. So if I go into the bullet prefab, I'm just going to not think about it. I'm going to start simple and add a rigid body component. Rigid body has a lot of options, right? It does a lot of things. This now makes it subject to gravity, for example. It has a mass, right? And so there's all sorts of ways you can configure this to do different things. Having a rigid body lets us use the physics side of programming now with this object if we want to. It probably means it's going to move a little differently. So let's take a look and try it again. Now that we just added the rigid body, we did not configure it. We just are going to see, okay, what's that do? So I make a bullet and it just falls through eventually, right? But it actually does trigger our onTriggerEnter function now, right? So giving it a rigid body helped and ruined it, right? Which is how physics tends to work in Unity, to be honest. So the reason, let's actually do this one more time. I'm going to go back here, zoom in on the player. It's kind of fun in the 3D. Maybe at the end we'll shift this from like a fake 2D to actually a 3D version because it looks pretty cool like this. So I'm going to hit play. And I'm going to launch a bullet and pause. Whoop, it was too quick. All right, I'm going to do it really fast. Now if I look at the bullet that's still on the field, right, it is at 0.8 -15. I unpause and repause, and now it's gone because its y-axis is gone down. It's falling through the ground, right? Because giving it a rigid body made it a physical ball or a physical capsule or whatever it is, right? So it's an actual object. So gravity's pulling down on it. It's pulling it down on the y-axis. And because our ground doesn't really have a collider, it's just going right through it. And so that's fine, but now we need to deal with that. So when you give something a rigid body, gravity's starting to pull on it, right? But that's okay. We have ways of fixing it. There's a checkbox that says use gravity, and we're going to say don't use gravity. Actually, I might have to do that again because that was play mode. So if I go to our bullet prefab one more time, I hope this is making sense. I'm trying to talk through it in the way that you might discover it if you try to do this on your own and show you the different pieces that all go into making it kind of work. All right, so now I launch a bullet. It both still works and it does not fall through the floor. So we're good. So now we have a way to hook in to the actual things happening in the game. And now we have a spot in code where we can say, all right, do stuff. So what we need to do is in this function, we're going to say, okay, is the thing you collided with an enemy? If it is, destroy it, right? So let's take a look at enemy. And because we know it inherits from entity, it has HP. So here's where it gets interesting. I'm going to make a function called take damage that doesn't live in the enemy script or even the player script, but because players and enemies are both going to need to take damage, and who knows what else might need to take damage, I'm going to put it on the parent class that they both share. So I'm going to make a function here. It's void because I'm just saying take the damage. I don't need to know anything. You don't need to give me an update after. You don't need to give me a new calculated value. Don't worry about it. For now, it's just telling it, take the damage, right? A function with the void type is just basically a command. You're like, do this, end of story. But in order to take the damage, there is something I need to know. So I got to say how much damage, right? So I'm going to say, in order to use the take damage function, remember here we're defining the function. We're saying, here's what should happen every time somebody uses the take damage function. We're defining it. We're not calling it yet. We're just giving the steps ahead of time. In order to do that, take damage. Well, how much damage? Good question. So we need an int amount. So we're saying, okay, computer, in order to use the take damage function, you need to know the amount. We're going to name a variable amount, and it's going to be an int, right? So again, I know this stuff is probably either really obvious and you've seen it before and you're like, I get it, or you're like, holy cow, this is a lot. Yuck. It's okay. Both are allowed. Welcome. This is how it works. It will sink in. And so yeah, so take damage, an amount. And so really what we're going to do is HP is now equal to HP minus amount. So if I start with 10 HP and amount is 1, at the end of this function, I'll be left with 9. Okay, easy enough. Now, I'm going to show you how most programmers would write this. Those two lines do the same thing. Its second line is just a shortcut. Line 15 is just a shorter way of writing it. So HP is now equal to what HP was minus whatever amount is, right? So you can say the same thing, shorter, with this, HP minus equals amount. Yeah. Okay, so that's a good start. But the benefit to doing it this way is because now we can be a little smarter. We can say, all right, every time I take damage, I need to check and see, am I dead? Right? Like if my HP has gone down below 0, I'm dead. So we're going to do if HP is less than or equal to 0, die. Now, hey, wait, does that sound familiar? I think we made a die function at some point, right? Did we make it for the bullet? Yeah, okay. So maybe we should have made bullet inherit from entity, but it doesn't matter. So we can just, repeat ourselves a little bit. So I'm just going to copy this, right? Void, I don't even need to copy it, it's short. So over in entity, I've specified a spot where I want to call a function called die, but I have not yet said what die means to the entity script. It's not smart enough to go out of the entity script and look at other places we might have written a function called die. Functions are part of the class they're inside of, right? So just because there's a function called die here in player bullet, entity does not know that function exists. So if we define die over here, it's a totally separate thing. So classes own all their own functions, and they can't talk to each other without jumping through extra hoops. So we're going to define a function called die over here. And yeah, so when die is called, it's going to destroy the current game object, right? Because entity is a mono behavior, we still have access to game object. And because we're not using entity directly, but we're probably using player or enemy that inherits from entity, now enemy can use those functions, right? Enemy can take damage, enemy can die, right? And so we're just, again, writing code in a way that means we won't have to repeat ourselves because both players and enemies will be able to die. Okay, so let's take a look at our enemy prefab because we need to make sure enemies have some amount of HP for this to work. So I'm going to double click here and I go to my enemy script and yeah, we gave it 1 HP. So that's perfect. That's probably what we want for now. Cool. So that should be all we need right now, right? We have a function called take damage, and take damage is smart enough to say if my HP gets too low, I should die and destroy the game object. So the thing that needs to happen is that when the bullet connects with an enemy, we need to say, hey, enemy, do your take damage function. That's the part where we start getting into talking between objects, talking between components. And that's a risk, right? Anytime in programming, in Unity, where you make things depend on each other, you know, like, oh, okay, like bullet can't do its job unless enemy is also doing its job. And enemy can't do its job unless game manager is also doing its job. Because then a bug in any one of those can mess up all of those, right? And so you want to try and keep things as separate as possible, but it's hard. There are always concessions in game development, in game design. And I'm going to try and instill this in you now. if you're the type of person who like could get hung up on writing the best possible code, don't. It's not worth it. Most games that ship have garbage code, especially now in the land of AI where it can help you find bugs and add features. Like, don't kill yourself trying to write perfect code. It's okay if your code is a little messy, as long as it works. And again, I'm not saying strive for that. I'm saying make it as good as you can, but don't be afraid to make some concessions. Don't be afraid to make some compromises, because I have wasted hundreds of hours trying to write the perfect UI system or the perfect way to do X, Y, or Z. And honestly, it was a waste. It was time I could have just spent duct taping things together and getting my game out the door. So do as I say, not as I do. And you know, don't sweat it if you have, you know, some components that depend on each other. You kind of have to, right? In a more advanced lecture, we'll get to something called an event bus system, which is part of the dark magic framework that helps get components interacting with each other in ways that don't make them as dependent. But it's a little more advanced, so I think I'm going to skip it for today. Just know you have options, and no option is bad if it works and helps you get the game out the door. The only thing you got to watch out for is if everything you do in code sucks. Eventually, it's going to be almost impossible to like edit the code, right? It's going to be a nightmare. You're going to like feel dread every time you open the file. So sometime on organizing, sometime on, you know, making your code look clean, sometime on writing comments to remind future you what you were thinking when you wrote that code, all valuable, right? So do a good job, do it right, do your best, but also accept that it's never going to be perfect, because we don't live in a perfect world. Okay. Sorry for my TED Talk. Let's continue. So here is the moment where we can do something, right? So in this onTriggerEnter function, this is the moment the bullet connects to the enemy, right? We first need to make sure the thing we're connecting to is an enemy. Are you an enemy? Then we need to go into its enemy component and say, well, since you're an enemy, I know you have an enemy component, right? The enemy script is on all of our enemy game objects. So we know that that's there. By virtue of the fact that it's an enemy, we know that it inherits from entity. It has a take damage function, right? So we need to say, is the thing I'm colliding with an enemy? Let's get that component. Let's make it take damage, and then we should be good. So instead of debug.log, I'm going to do, you know, we've got this other, right? So again, this function came with Unity. It's part of Unity. I didn't get to name any of this stuff, but, you know, this is always the pattern you follow. So it gives us a collider called other. So I'm going to say the following. If there's a few ways we could do this, right? We could check the name of the game object to see if it contains the word enemy. That's usually bad. You don't want to be looking around for strings and stuff like that. Plus, when you instantiate, it usually makes it say clone or something, or enemy1 or something. So we don't want to depend too much on the specific name of the game object. You know, a better way we could do it is if we go into the enemy prefab, let's just use a tag, right? So a tag is, it's like a label, right? It's stupid that Unity called them tags. I'm going to nip this in the bud right now. So this is an important thing to know, because in every software I've ever used, a tag is a label that you can apply to something. And an object can have multiple tags, right? I can tag something as self-help. I can tag something as to-do. I can tag something as, you know, overdue, right? Like think of like a to-do list app where you have different items on a to-do list. A single to-do item could be for self-help, it could be overdue, and it could be whatever the third thing that I said was. In Unity, that's not the case. Tags are one. I hate it. It's stupid. I wish they changed it. It's just frustrating. They should call it something else, because a tag implies you can have multiple and you can't. So we're going to give enemy a tag called enemy. It doesn't come with one by default. So when you first try to do it, you'll get this menu over here, and you're going to click add, and we're going to say enemy. Just pay attention to your capital. If you made it capital, great. If not, great, but just be consistent. I would recommend doing it capital. And then we're going to go back. When you create a new tag, it doesn't add it. So you have to click again and manually add it. And so now every enemy that gets created is going to have this tag called enemy. It's like a label, right? So all that to say, now if we go back over here, I think we can say, what's it, game object dot tag? equals enemy. I think that might be the wrong syntax, so it's probably going to give us a bug. I also don't remember everything about Unity by heart every time. So, but we're going to do this in steps. So if the other game object has a tag of enemy, right, then we're going to debug.log so we can see. Now, I think it's going to be like blah, blah, blah tag is not available. Oh, okay, it might work. I do some work in Godot, and so sometimes things are different, so I kind of fry my brain on the specifics of things. But I shoot, and it says, got him. Okay, great. So that worked as expected, so that's great. So you can just say other.gameObject.tag. So if collider, this other object it gives us is of type collider, which means it's like a physics object that's able to collide with things, right? And so we're going to just check the game object attached to that, and then the tag attached to that, is it enemy, right? And so that's great. So it worked, it is. So then we're going to do this. We're going to say, okay, so that's a typo. There we go. So this probably looks like a gnarly line of code, but I'm going to explain it bit by bit. So var is a keyword to declare a variable when you don't feel like specifying the kind of variable it is. You can't use it in most places. It is arguably a bad habit. What you should probably do is think about what kind of thing you're going to be getting from the function you're using to ask for a thing. So our goal, let me back up. Our goal here is, okay, we figured out that the thing that collided with us is an enemy. So I want to access its enemy script. And remember that scripts are components. So if I look over here in Unity, enemy has a mesh renderer component, a box collider component, and an enemy component, right? Our script is a component. So I need to access that script so that I can have it take damage, right? So I hope that's making sense. So over in player bullet, if the thing I'm colliding with has the enemy tag, we know it's an enemy. I'm going to get its component called enemy, right? That in between the angle brackets here, that name is the name of one of our scripts or one of our components. So I could do enemy, I could do mesh renderer, I could do box collider, I could do, rigid body, I could do all sorts of things. But because our scripts are also components, I can do it as enemy. What that means is, instead of saying var here, I could say enemy, because I know the thing I'm getting is of type enemy. When I say is of type, it means it came from the class of enemy. I know this is a lot of programming jargon. Don't worry if you're not getting it. Let it wash over you. You'll eventually get the hang of it. A lot of it's subconscious pattern stuff. So just, don't sweat it if you're not totally following. I'm just trying to explain this gnarly line of code, right? So create a variable called enemy component. I named that. I could call it panda if I wanted to, as long as I was consistent. But this part is referring to the type of thing it is, the class that it came from. And that's enemy, which we wrote up here in enemy. So all good. We're using this other.gameObject.getComponent function, right? Okay, and with this function, it's weird. You've got these angle brackets. And so I have to tell it what kind of component I want to get, which makes sense actually, because if we look, every game object has many components, so it would be confusing. So it's a way for us to specify the specific kind of component we're trying to get access to. The reason we want to get access to it is so we can use it in code to do stuff, right? So assuming this line works as expected, we're going to get the specific instance of the enemy script, the enemy component that's on the specific enemy we hit. Okay, and now we have it in a variable called enemy component, right? Okay, hang in there with me. So then I can say, because I'm the bullet, right? We're in the bullet script. I want that enemy component to run its take damage function for 1 damage, right? Now we're so close to this working, but we're not quite there yet. Let's check it out. Error. It says entity.takeDamage is inaccessible due to its protection level. Classic. So here, this is one of those coupling things I talked about. These components are now becoming dependent on each other. So player bullet needs enemy to work a certain way so that it can make the enemy take damage. It's fine. It's no big deal. We go to the enemy script and we say, oh, right, it's not enemy because we're using entity for this. So we go to the entity script. And instead of saying void take damage, we just have to say, hey, it's public. Other people can use this function too, right? So other scripts can use this function too. You know, and a good example here is I probably don't want other scripts to be able to force it to die, right? I can let the entity script itself determine, based on the damage, whether or not it should die. So we're going to keep the die function private. Player or player bullet should not be able to directly tell an enemy to die. That doesn't seem fair. But we can tell it to take damage so that it can then calculate itself whether it wants to die. So that's the idea behind private and public functions. It's all about keeping your code clean and saving you from yourself, not making mistakes that you're likely to make. That's why C# makes such a big deal about the types of variables, about the public-private stuff. It's ultimately to help you. It's so that you don't do unexpected things that will crash the computer. Seems like a lot of work up front. You know, if any of you have done web design, JavaScript is like the Wild West. You can do whatever the hell you want in JavaScript. And in some ways, it's a total mess. And in some ways, it's very freeing. You know, it's like var this, var that. I don't care about types. I don't care about returns. Everything's optional. So different languages have different feels. C#, I actually really like. It just takes a lot of getting used to. I'll fully admit that. Okay, so we made take damage public. So now the player bullet is saying, okay, when I connect with an enemy, get its enemy component, get its enemy script, and then tell it to take damage 1. That error goes away. And let's look at this warning, right? Player bullet.damage is assigned, but its value is never used. Huh. Okay, let's look at that, right? Instead of just saying, hey, take 1 damage, that's hard coding a number. That's not good. It's hard coding a number. It's hard coding a value. It's called a magic number in programming. Because 6 months later, I might be like, where's this 1 coming from? Why did I pick 1? Why didn't I pick 2? Blah, 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 blah. So what we should do is use a variable for it. Well, hey, we already set that up, right? The default that we set anytime we are looking for the damage variable in a bullet is 1. So instead of putting 1 here, I'm going to put damage. That might seem like, what's the difference, right? But think about it ahead of time, right? Maybe as a game designer later on, I say, oh, well, the default bullet actually needs to be 2, right? Maybe I change the hit point scaling and 2 actually feels better in terms of game design. Or maybe I want to make it so that there's a certain power up that doubles or triples your damage. And now that it's a variable, that's easy to do. Back when it was a hard-coded 1, it would have been harder to do that, right? So there's always, you know, the patterns and the annoying pedantic things that programmers tell you to do. There is a reason for it. And sometimes you just have to be like, okay. So yeah, so instead of just saying take 1 damage, we're saying take damage and the amount is what my current damage is, right? Maybe we'll have bigger bullets someday, or maybe we'll, you know, again, get power-ups or something. So let's try it. So we should have no more warnings, no more errors. Oh no, they're descending upon me. Blammo. You see it? I killed 1. Blammo. Blammo. Very satisfying. Wow, it almost feels like a game. Holy heck. Okay. So that was already 45 minutes. So we might not go too far, but let's get the player to take damage as well, right? Currently, our enemies do not shoot bullets. I think we're just going to make it so that if the enemy hits the player, the enemy blows up and the player takes damage, right? So it's the exact same thing we just did, but sort of a different flip, right? So let's take a look at what we're working with. If I go to my scene and I look at my player, player's got a sphere collider, nothing else. We know that our enemies do not have, you know, a rigid body or anything like that. You know, and here we could think like, oh, maybe instead of giving the bullet a rigid body, I should have given the enemy a rigid body. You know what? Don't sweat it. It doesn't matter. It's all the same. You can always change things if you want, but you just need it so that the collisions work, right? So one of them tends to need a rigid body. So I'm going to give my player a rigid body because there's one of him, but there's tons of enemies, right? And so the thinking there is if we have 100 enemies in a scene, it's a lot more work for Unity to calculate the physics positions of 100 separate rigid bodies, right? So just thinking a little bit ahead in terms of optimization, don't over-optimize, it's a bad habit. But in this case, if I can get away with one extra rigid body instead of dozens, right, probably good. So I'm going to go to the player. I'm going to add a component called rigid body. I'm going to say, you know what? Don't use gravity. I don't want to mess with gravity. He's just going to go right through the floor. So no gravity. And we'll start with this. And now we want it so that if an enemy connects to the player, we want the player to take damage. Well, the good news is we already wrote that code, right? Because we wrote it in entity, which player also participates in. Awesome. So let's make it so that when the enemy hits the player takes a damage, right? So if we look over here at player, how many HP did we give player? If we click on player, we can see that we start with 3 HP. Okay, great. One thing I want to point out too is player is also a prefab, but we just made a change to the in-scene version of player. That's maybe slightly confusing, right? Because which one is the truth, right? Well, once you're using prefabs, the prefab is always the truth. The one in your scene is a sort of instance of the prefab itself. And so you'll look, when I added the rigid body, it's a little hard to see, but on the left side of the component, there's like this blue line. That's your heads up that like, hey, this is different from the prefab. If I open the player prefab, I go to my prefabs folder, I click player, I look at this. Oh, hey, wait, it looks a lot different, right? What's up? This player, you know, it doesn't have a rigid body, right? It doesn't have some other things. And so if I go back to the scene version, to fix that, I can say, oh, you know what? Like I made a bunch of changes to this, right? I'm using like the material and the rigid body. I can apply these changes back to the prefab itself by going up to overrides and just saying apply all, right? Now, if I look, there's no more blue here. And if I open up my player prefab again, here we go. Now the rigid body is part of it, right? So again, it's one of those things that is easy to miss, easy to mess up, and can be really frustrating. It's like changing values when the game is running and then they reset and you're like, oh shoot, I didn't mean to do that. Or, you know, so just always be aware when you're using prefabs, they're so useful, so valuable, but it's very easy to make that mistake. Experienced game devs do it all the time. So just keep an eye on it. And again, when you make a change and you want to apply it back, you use that override button that is up here, right? You say overrides, and then there'll be a button that says apply all, and then it'll do it for you. Okay, so now the player has a rigid body. Let's just make sure that didn't change the way we move or anything like that. You know, again, rigid bodies can change things around, but looks good. Everything still works as expected. Awesome. So now we want to go to the player, and we're going to say, well, here the enemies are not using the is trigger, right? We're going to leave it as a collider because we want them to take up physical space, right? So, you know, we might change the way this works. It's not totally fully baked yet, but just, you know, for now we're going to go, okay, this one is not a trigger, right? The bullet, I think we made a trigger, right? Yes, we did. And so just to show you the other way, we're going to do enemies as just standard colliders, not triggers. But the player, when the player collides with an enemy, we should take some damage. So go into player, and instead of on trigger enter, Unity also gives us on collision enter. Very, very, very similar in the way it works. One thing to note is that this gives us a collision called other, and in bullet, when we're using a trigger, it gives us a collider called other. So there are some slight nuances to how they work. For now, it really doesn't mostly matter for the things we're doing. But just know that, you know, when you are further along in your advanced game development physics simulation career, it might be a thing. But for now, we're going to keep it pretty simple. We're going to say, is the thing that just collided with me an enemy? If so, I'm going to take some damage, and that enemy should die, right? So if other dot game object, I can type, I swear, dot tag equals enemy. If other dot game object dot tag equals enemy, there's going to be ow, right? Let's see if this works. I like to test at every step. Programmers call this a sanity check. It's like, I could write that code and keep going and write what I think should happen next, and then write what I think should happen next, and then write what I think should happen next. But you do that a few times, and if there's one bug in there somewhere, well, you don't know if it's in the first line you wrote or the sixth line you wrote, and then you have to test all of them, right? So I like the sanity check approach. I do something, I'm like, I'm pretty sure this is going to work, but I like to double check before I continue. So if the other thing is an enemy, say ow, right? Let's see if this works. So I hit play and watch the game in the bottom right. Didn't feel slow until right now. We get this, we get. Okay, so, all right. We didn't get any ows. So something is not working the way we expect. So let's figure out what and why. So my player has a collider. It's not a trigger. It has a rigid body. A bunch of stuff just collided with it, so something should have happened. I'm going to double check the positions. I mean, they're clearly on top of each other, right? Like all of the things are right on top of each other, so that's not the problem. They should, in fact, be colliding. So if I look at the enemy, let's look at this clone, right? It has a box collider, yeah. So yeah, all right, let's figure out why. And this is why colliders can be annoying, because you're like, that should have worked. So first, let's maybe then, I'm glad we did the sanity check because I thought this would work, but it didn't. So I'm going to comment this out, and we're going to like, are any collisions working? Like, you know, maybe I messed up something, maybe the tag doesn't work or something like that. So I'm just going to do another test. Is it colliding at all, or is it truly just confused and not seeing anything? And I'm kind of glad it went wrong, because that shows you how it really feels to be a game dev and to work on stuff, because that is what happens. Okay. All right. So interestingly, we started with a single collision, right? Which is probably just the game, the player, and the floor, which is interesting to me. Yeah. To confirm that, let's go ahead and be smart. Instead of debugging a message of gibberish, we're going to say other.gameObject.name, right? Every game object has a built-in name variable. So let's take a look here. And when I hit play, it's immediately going to be like ground. Okay, so he is colliding with the ground, which is funny because the ground is just a simple box collider, exactly like the enemy, and yet the enemies aren't colliding with him. It's kind of funny. It's kind of interesting. All right, let's try again. And so I'm going to sit here for a minute. It's colliding with the ground. And one last time, just to make sure I'm not totally crazy, I'm going to let the enemies hit me. And then it's not going to work, and it's going to be sad. Okay, so for some reason, it's not considering those collisions. So I'm going to double check, make sure I didn't like, you know, it's not a trigger, right? So the quick answer is probably that it'll work if I add a rigid body to the enemy. And this is why I hate Unity physics, because it feels like the rules are inconsistent. And again, I'll fully disclaim, I typically use 2D, so I could be making some dumb mistake. But let's see if adding rigid bodies did that. Yep. And now the collision happened and he pushed me off a cliff. Great. So by adding rigid bodies to the enemy, they now take up physical space. That's cool. That works. I was kind of hoping we didn't have to do that, right? Let's experiment a little bit. You know, I know we're going long, but I'm going to go to the player and I'm going to say, well, fine. Then I guess I don't need a rigid body on the player, right? Remove component. And we're going to hit play. And I think I'm now remembering the rule is for triggers, only one of them needs a rigid body. And for collisions, both of them need rigid bodies. I think that's what we're dealing with here. Or there's literally no rhyme or reason and it worked better this time. That's very confusing. So I might have to actually reflect and think about why, because that truly is so silly to me. So if the enemies have a rigid body, it works. But if the players, oh, okay, yes. See, and this, I'm actually an idiot, one, but two, I'm glad, because you too could run into this mistake. I put the function on the wrong script, right? So let's go back to the way I want things to be, right? So I'm going to go to the player, and I'm going to actually revert my changes. So I'm going to go to overrides, and I'm going to say revert all. I removed the rigid body, but I actually want it back. I want the player to be the one with the rigid body so that Unity only has to manage one extra rigid body instead of 20. Okay, so he's got the rigid body. I'm going to go to the enemy, and I'm going to say, you do not get a rigid body. That's too many. I don't want to deal with that. And if I go to the enemy prefab, I did add it here, so I'll just delete it here too. Yeah, sorry, this is probably a little confusing because it went not right, but honestly, it's important. I did this on purpose. I mean, I didn't get it wrong on purpose, but I went through this process on purpose because this always seems to freaking happen, at least to me, when I'm messing with components and physics and rigid bodies and all that. It's just an easy thing to get a little wrong, so we're going through it together. But the punchline is now, if I hit play again, it'll collide with the ground, but it won't collide with the enemies when they finally hit me. Nothing happened. Okay. And so the punchline is I put this on collision enter function on the wrong thing, right? So if I put this function on the enemy, so I just copied and pasted it, right? Same deal, on collision enter, get the other object's name, and let's see if this works now. Do 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 boo 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 do boo 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 do do. Oh mother heck! Why does that not work? Okay. Collision other debug.log other object.name. Did I mess this up? The player has a rigid body. Sphere collider. Okay. We had it working the other way, but I want it to work this way, right? I don't want it to have a rigid body on everything. That's expensive. When we say it's expensive, it means it takes up a lot of computer processing. Okay, player has a rigid body and a collider, not a trigger. Enemy has the box collider. Oh, nope, yep, nope, that should be right. And so the script, let's try making it a trigger and then changing it, but will that mess up the bullet? Sorry, now you're really seeing my process because I am a bit surprised. Okay, the bullets still work, that's fine. So if we make it trigger, and I'm just testing, you don't have to follow along with that per se, but let's see if this works the way we want. And I kind of liked it taking up space though, you know, but that still works. And then let's see over here. Bam. Okay, something is weird. Nothing is working the way I want it to work. So I got to think for a minute. Might have to edit this out. Think happy thoughts for a second while I give this some thought. We didn't change layers. On collision, enter. Well, hey, you know what? You guys are. Well, let's go along for the journey here. You can see my nightmare of a Chrome, a lot of tabs, Unity, rigid body, not colliding, right? 40 billion results. Let's see what it says. At least one rigid body for a collision. At least one. Yep, player has it. Colliders on both. Yep, we both have that. We're using 3D. Is trigger is not set. Is kinematic is not checked. Collision matrix, we didn't play with the layers, right? Direct transform manipulate. Oh gosh, every time this gets me every time. Okay. Every time. So because I usually do 2D and because I do a lot of like UI heavy games and RPGs, I don't spend a lot of time in the world of colliders. I'll fully admit that. But here's the problem. The real problem. So thanks for staying with me. I'll probably leave all that in because of the process of debugging. It's important. So the problem that's happening is when you're doing real collisions, that has to happen in the world of physics. Has to. And the world of physics is a little different. So here we have the player, you know, for example, we're moving the player's position with transform.position. The enemy, we're moving the enemy's position. And I actually saw this coming at the beginning of the video and completely forgot. Dang it. We're moving the enemy here by manually moving the position, right? We're saying transform.position now equals blah, 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 blah. The problem is when you manually numerically change the position value, that does not participate in physics. It goes around it, right? So in order for collisions to work the way you expect, movement has to happen at least partially through physics. So what does that mean? For the enemy, instead of saying, let's see, transform.position, I feel like it should still work. This is annoying, but it must be that. But then why does it work with the ground? Okay, I'm going to figure this out, and then we're going to end the video because this is going to go long, and I'm probably going to have to cut it down a little bit. The enemy doesn't have a rigid body. That's the whole freaking point. I don't want to give it a rigid body because that would be expensive for so many. That would make all of this easier. We'd be done by now if I had just been willing to do that. But now that I've set this goal for myself, let's figure out how to do it. On collision, enter. If we go to Google, yeah, it wants us to be using rigid body.move position. But the thing is like, moving objects via transform.position teleports them, often bypassing the physics engine's checks. Yeah. Okay. But, you know, I don't think that's it. Because even if I don't move the player at all, it should still be hitting it, right? Because the enemies come down. And yet, no. Right? So I don't think that's a physics problem, but I guess it could be. Here, why don't we get crafty? I'm going to pick one of these. I'm going to delete a bunch of enemies. And now it worked. Hey, wait a minute. How the heck? So I'm not crazy. Unity's being dumb. Ta-da! All right. So I think maybe the fact that there's so many happening all at once is frying its brain, maybe? Because you saw that, right? When I deleted the extra enemies, it started to work again. So let's try this. So I'm going to hit play. I'm going to hit pause. I'm going to delete all the enemies but one. So there's just the one lone enemy now. So I'm going to hit play again. And I'm not even moving the player. So I know it says we need to be doing movement differently, but that's not even a factor. So now the one lone enemy comes in and it didn't work. But if I move, then it works. Fascinating, right? So it does seem to sort of be related to that issue where mixing transform.position manipulation and the physics system is generally a bad practice. This is why. But I'm kind of just thinking like, ugh, I wish we could do it because, I don't know. I, again, would love to only have one rigid body and not 40. But I think the way to get this going, the way to fix this, is to just bite the bullet and give all the enemies a rigid body. Plus, then they will be physical things that can bump into each other, and that'll be more interesting. So I may have edited out a bunch of that because it will probably just confuse you more to see me bumbling around like that. But maybe it's helpful for the debug process. Maybe I'll make a note that says skip from blah to blah if you don't want to see a really annoying debug process. But I think it is kind of helpful, right? Because this is the kind of stuff we run into. As you see, the collisions kind of work. They just don't work like super great, and they seem dependent on either randomness or movement or something like that. Like, you know, as long as I move, yeah, then it'll work, right? But that's so interesting, right? So I wasn't way off. It kind of works, but also not great. So for more reliable, and this is the problem with Unity physics, if you're going to use any of it, you got to use all of it, right? So here's what we're going to do. I'm going to go back to my code, and I'm going to leave this. I'm going to take this out. And now that I know what's happening, I can put it back to the version of the code we want, right? If the other game object is an enemy, say ow. Awesome. And let's just make sure that still works, you know, in the broken kind of half working way that it is. If I wiggle, then it seems to notice the collision. So I'm going to let it happen again. So I'm getting the ow. All right, awesome. Great. So, you know, we don't want to design it around this broken behavior. So what we're going to do is we're going to bite the bullet, and we're going to make all the enemies have a rigid body. So I'm going to go back into Unity. I'm going to go to my enemy prefab, and I'm going to say, all right, all you dudes get a rigid body, and all of them are not using gravity because we're sort of in this weird 2D thing. And now when I hit play, let's see if it's any different. Dun 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 dun. Okay, so now it works as expected, right? So fine, you win, Unity. We'll do it your way. No, it's fine. And again, it seems inconsistent because I did not change the movement, right? We're still using transform-based movement, so who knows? But anyway, hopefully you skipped that big chunk of me being like, why is it not doing what I want? This always happens with 3D colliders, man. Okay, anyway. So instead of just saying ow, we want to say we want to take a damage. For now, we are going to just hard code it with a 1 because I haven't thought through how I want that to work. And then we know player knows how to take damage because we're inheriting from entity. So we have access to all of this. So that's great. But then importantly, we want to have the enemy take damage too, right? So we can't tell it to die because the die function is private, but the take damage function is public. So what we can do is we can say, okay, I'm going to take a damage, and then I'm going to say other we're going to get the enemy script off the enemy. We're going to store it in a variable. The variable will be of the enemy type. We're going to call it enemy component, just like we did before. So I kind of wrote that in a weird way, but let's look at it. So making a new variable called enemy component. Its type is enemy, which means it's made from the class of enemy that we made in our script, and it's the component in the inspector that's on the game object, right? And we're getting it, and we're storing it in this variable. This whole function says, go give me that component so that I can have access to it in code so that I can then do this. Right? And again, hard coding it because this has gone on too long and I haven't thought through how I want that to work. But now if I hit play, anytime an enemy bumps into me, it's going to die. Okay, one more error, because why not? All right, let's see. So, oh, very interesting. Okay, so we're getting this error over and over again, right? The type of Unity engine.transform, the object of type transform has been destroyed. So you should either check if it's null or not destroy the object, right? And that's coming from, move my dumb face. enemy line 15. So if I go in here, move to target. So that it's interesting because the enemy script is still running, yet it should be dead because we used die, right? So die, destroy game object. That should also destroy the components. So this is off the rails. Wow, what a video. Okay, trying to make things smarter and easier tends to make them harder. Careful, that's programming in a nutshell. So this move to target function should never happen if the game object is dead, right? So let's just really carefully look. So in entity, if I die, I'm destroying this game object. So that means this shouldn't be happening. You know, in the player, I'm saying enemy take damage. So it seems to be working. The object of type transform has been destroyed. Your script should either check if it's null. Doesn't usually work this way. All right. Enemy component dot take damage 1. Destroy game object. Hey, you know what? Let's go, okay. Unity. Does destroy the game object, all its attached components, and all its children. If it appears it's not getting destroyed, likely due to one of the following reasons. Referencing a component instead of a game object. Yep, that's what I thought, but that's not what we did. Destroy game object. That worked. Destruction is not immediate. Destroy method queues the object for removal at the end of the current frame. Destroying a prefab instead of an instance. C# reference. Logic error. Yeah, okay, so what it wants me to do to fix it, which I've never really had to do before, so I'm kind of like annoyed, is to be like, if I still exist, then move to target, right? But that's stupid. I shouldn't have to do that. And it's because physics happens at a different speed than the rest of Unity, which is annoying. So our code to check movement happens in update. Physics happens in something called fixed update. It goes at a different rate than the normal update. So this might cause some problems, but I wonder if it will fix this one. So I might edit all of this out, but let's get to the end and then I'll decide how much of this to give you. So let's see what happens. Are we going to get a bunch of errors? Yes. What the hell? Okay. So I will say every time, so I'm changing that back to update. Every time something like this happens and I start having a crisis of faith and being like, Unity sucks. Why does it do this? This is so obvious. This is 101. This is basic. I'm usually doing something wrong. So the player doesn't get destroyed, right? If I go to Unity and watch the hierarchy in the game, because if the player gets destroyed, it no longer has a target, and that makes sense to me, right? But I don't think the player is getting destroyed. Oh, yes, it is. That's okay. So we're back. That's the problem, right? So the enemies still exist, but the player got destroyed. Okay, see, I was the problem. I missed something. It's not Unity's movement system or physics system being an idiot. It's me being an idiot. So let me explain what happened. We did write in the code in the player to take the damage, right? If I get hit by an enemy, take a damage. As soon as I get hit by 3 enemies, the player is done. The player is dead. The player is destroyed, right? But the problem is, if the player is destroyed, we haven't handled that case yet. The game is still like, there should be a player, right? That makes sense. So the problem wasn't the enemy per se. The enemies are getting destroyed properly. The problem is that the enemy depends on player, right? And this is what I'm talking about. I'm going to probably leave this in, even though it's annoying, because it is an important lesson. This is an area where these two components, these two game objects, are tightly coupled. Enemy needs player to do its job, at least the way it's written right now, right? So as soon as player is destroyed, enemy freaks out. I got no target, blah, 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 right? So what we need to do is, over here, on line 21, we're saying, get me the position of the target, right? But the problem is, if the player is destroyed, then this means target is no longer there. So it's trying to reach something that was destroyed, the position of something that was destroyed, the position of something that doesn't exist. So it's like, so what we're going to do is we're going to say, if that target exists, do this. There's a few ways to do it. I'm going to do the lazy one. Let's see if it'll let me get away with this. This says, if the target exists, get its position, right? If not, it'll probably just be a 0 there. It might give us an error, but it might just, because it doesn't matter. If the player dies, cannot convert. Okay, fine. So we're going to do it the right way. So we're going to say, if fascinating. Didn't run into a single one of these things when I was building the game myself in advance, but I love it. This is how we learn. This is how you can see the right way to debug things. So move to target still works the same way it did, but we've added a check. This is what's called a null check. You make sure the thing you're depending on exists before you depend on it, right? So on line 22, if target is null, what's null? What's that mean? Null means not existing. Null means there's nothing in the variable. You made a variable and there's nothing in it, or you had a variable and whatever was in it is gone, right? So that's what null means. So if the target is null, return. We talked about returns earlier. If I have a function with an int here as the return type, then it will return an int. With void, you don't return anything. If you use return in a void, it just stops. It's just like, I'm done, right? Which is good, because if the target is null, we want to be done, because then we'd go on to the line that's dangerous, the line that depends on the thing that might not be there, right? Which crashed the computer. So let's save and hit play now. And again, honestly, this isn't really a huge issue, because if we were to continue, we'd be building the game in such a way that if the player died, everything resets. So it's like a dumb thing that's easy to miss. But here we go. Player gets destroyed. And now the enemies are just like, I don't know. I love him floating off into space for no reason. That's kind of fun. So, wow, what a battle. So we have it so the player can take damage, the enemies can take damage, our bullets actually work. Believe it or not, that was a pretty productive video. I'm sorry for the long wandering in the desert that we did, but I'm gonna leave it in. I'll put some notes in the comments so that you know to skip through that part. But it might be helpful to see me go through exactly what you probably go through as well. We run into stuff where Unity doesn't do what we expect. We think it's one thing. The answer is actually something else. We finally find it. We feel dumb, but then we feel happy because we've made progress. So total chaos. Hope you guys can get through this. I'll try and make it easy for you to skip to the parts that matter. But yeah, thanks for watching. We're going to come back, and next time we're going to get some UI. We're going to start keeping track of score. We're going to make it so you can win. We're going to make it so if the player dies, it resets. It's going to start to feel really like a game at that point. We're getting there. We're getting there. So this was probably the most technical and annoying lecture, but the next one will be better, I promise. All right, see you then.